channel. In this video, we are going to discuss factoring polynomials. Okay, let us just focus on Lesson 1. Lesson 1 is all about factoring by greatest common monomial factor. Of course, we have our objective. After watching this video, you will be able to factor polynomials completely and accurately using the greatest common monomial factor, or the GCMF. Okay, let us recall that factor is a number or algebraic expression that divides another number or expressions evenly, that is with no remainder. Examples here. Number 1, the factors of 4 are 1, 2, and 4, as this can divide 4 evenly. Okay guys, if we will make use of these factors as a divisor of 4, we will obtain the result with no remainder. Alright? Number 2, the factors of 2x squared are 1, 2, x squared, 2x, 2x squared, as this can divide 2x squared evenly. Okay. Now let us answer this activity entitled Pieces of My Life. Find the possible factors of the given number or expression below. Okay, then choose your answers from the box. Alright, so these are the given expression, and our answer here are what we called factors. Okay, number 1 is 8. So what are the possible factors of 8? Alright, so the possible factors of 8 are 2 and 4. Number 2, 2x. What are the possible factors of 2x? Okay, 2 and x. Then, number 3, possible factors of 5ab. So we have 5a and b. Number 4, possible factors of 12c. So these are the possible factors. We have 2, 3, 4, 6, and z. For number 5, 20x. The possible factors are 2, 4, 5, 10, x, and y. Alright, I hope guys that your skills in factorization was refreshed. Okay, let's continue. Okay, let us make use of this illustration. Given the area of a rectangle, of the length rather, is x plus 3, then given the width is 2. So the area of a rectangle is the product of the length and the width. Or we can use this formula. Area of a rectangle is length times width. Okay, let us find the area of a rectangle using this formula. Okay, from this formula, we are going to substitute the value of the length and the width. Okay guys, do not be confused of the position of our given here. Once we are dealing with multiplication, the position of the variables or any numbers can be interchanged. Alright? So it doesn't matter. We can still obtain the exact result. Alright. So by applying the concept of the distributive property of multiplication, we will be able to obtain the product. So if we will multiply 2 and x, we will obtain 2x. Then multiply 2 and 3, we will obtain 6. So this is now the area of a rectangle. 2x plus 6 square units. Alright. Using the area of a rectangle 2x plus 6, notice that 2x plus 6 can be written as 2 times x plus 2 times 3. Alright? So, what we did here, guys, we factor out the first term, and the factors are 2 and x. Then, so with 6, the factors are 2 and 3. Okay? Notice that the common factors is 2 in both terms. Alright? Now, in this pattern, in this format, we will isolate the common factor, which is 2. Then, the other factor will be written inside the parentheses. So, this is now the factors of the given area of a rectangle. Okay? And 2 is called the greatest common monomial factor. Recall that by distributive property, 2 times quantity x plus 3 will go back to its original form, 2x plus 6. Hence, 2 times quantity x plus 3 is 2x plus 6. Note guys, when you factor see to it, the product of these factors is always the original expression or polynomial. Okay guys, uh, what we are what actually the method that we applied in this situation is we actually work backward in order for us to go back with the original given of the length and the width. So this is what we are going to do all throughout with this with our discussion. All right? Okay. Example number 1, find the GCF of each pair of monomials. Okay, we have problem A and B. So let us first answer letter A. So solution. Okay, so this is now the steps in finding the GCF of a given term. Alright, step 1, factor each monomial. So we need to factor first the numerical coefficient, which is 4, and the factors are 2 and 2. Then also x cubed, the factors are this one, the 3x's. Okay, if you want to go back with this expression for x cubed, just multiply the factors. Okay, then we will do the same in 8x squared. So the factors of 8 we have here 2, 2, 2. Okay, if we multiply these factors, we will go back to this number. Then the factors of x squared, we have 2x's. Alright, then for step 2, identify the common factors. Okay, and the common factors are this one. Okay, we also have this one. Alright, then step 3, find the product of the common factors. Okay, meaning to say we need to multiply the numerical, the GCF of the numerical coefficient and the GCF of the variables. Okay, so 2 times 2 is 4, then x times x is x squared. Alright, so this is now what we call the greatest common factor of 4x cubed and 8x squared. Alright, let's continue. For letter B, the expression, the terms are 15y raised to 6 and 9z. Okay, we will follow the same steps. Number 1, factor each monomial. Okay, first we need to factor out the numerical coefficient, which is 15. The factors are 3 and 5. Then the variable y raised to 6. So these are the factors of the variable y. So we have 6 y's. Then we will do the same in the second term. We have 9. So the factors of 9 is this one, 3 and 3. Then z. Alright, then for step number 2, identify the common factors. Alright, so this is the common factor. Then step 3, find the product of the common factors. Alright, so note that 3 is the only common factor. So hence 3 is the GCMF of the terms 15y raised to 6 and 9z. Notice that in the examples, prime factorization is used to find the GCMF of the given pair of monomials. Okay, next example, number 2. Write 6x plus 3x squared in factored form. Okay, So we will follow the steps. Number 1, determine the number of terms. In this case, we have two terms, 6x and positive 3x squared. Then number 2, determine the GCF of the numerical coefficients. Okay, these are the process. So these are the numerical coefficients of the given expression. The factors of 3 are 1 and 3. Then the factors of 6, we have 1, 2, 3. Then we will determine the common factors. We have 1 and we have 3. So since it is the greatest common factor, we will choose 3. So therefore, 3 is the GCF of the numerical coefficient 3 and 6. Step number 3, determine the GCF of the variables. Alright, the GCF of the variables is the one with the least exponent. Okay, so these are the variables of the given expression. We have x and x squared. So we will choose the variable with the least exponent, and that is x. So this is the GCF of the variables. Okay, now next step, we have find the product of the GCF of the numerical coefficient and the variable. So meaning to say, we will multiply the two. So this is the GCF of the numerical coefficient, and this is the GCF for the variables. Then the result, we have here 3x. Then hence 3x is the GCMF of 6x and 3x squared. Then next step, okay, this is step number 5. Find the other factor by dividing each term of the polynomial 6x plus 3x squared by the GCMF 3x. Okay, these are the process. Divide each term by the GCMF. Alright. Okay, and then next step, rewrite each term as a product. So what we did here, guys, we factor out the numerators. Right? First, the factor of the numerical coefficient 6, we have 3 and 2. Alright? Then factors of 3x squared. So 3 can no longer be factored out. So only the variable x, we have x and x. And then in this step, try to recall the concept of division of polynomials. Right? When you are going to divide the same basis, subtract the exponent. So the exponent of the variable x will become 0. And once the term being raised by 0, the result is 1. Alright? And we could also apply the cancellation. Okay? So this term will be cancelled out. So what will remain? The first term we have 2, then positive x. So this is now the other factor that we are looking for. The next step, we have write the complete factored form. The complete factored form of this given expression is 3x times quantity 2 plus x. So this is now the factored form. Okay? Next example. Write 12x cubed y raised to 5 minus 20x raised to 5 y raised to 2z in complete factored form. Okay? Do the same steps. Determine the number of terms. So in this case, we have 2 terms. Okay? Try to recall, guys. And in algebraic expression, the only operations that will separate the terms are addition and subtraction. Okay? So in this case, again, we have 2 terms. Okay, then determine the GCF of the numerical coefficient. Okay, these are the process. So these are the numerical coefficients 12 and 20. So these are the factors of 12 and these are the factors of 20. So we determine the common factors. We have 1, we have 2, and 4. So 3 here is not included. Then we will select 4 because 4 is the greatest common factor. Okay, so this is now our GCF for the numerical coefficient 12 and 20. Alright, next step. Determine the GCF of the variables. The GCF of the variables is the one with the least exponent and is common to every term. Okay, so these are the variables in each term. We have x, y, and z. Let us first work with the variable x. So we have x in the first term, we have x in the second term. Then we will choose the less exponent. So this one, x cubed. So this is the GCF for the variable x. Then for y, we will choose y squared. Then for z, since we do not have z in the first term, so meaning z is not common. So this is now the GCF for the variables. Alright? Then next step, find the product of the GCF of the numerical coefficient and the variables. So we will multiply. So this is the GCF of the numerical coefficients, and this is the GCF for the variables. So by multiplying, this is the result. This is the product. 4x cubed y squared. Okay. Then next step, find the other factor by dividing each term of the polynomial. Alright? So this is the polynomial again. Then we will divide this polynomial by our GCMF. Okay, these are the process. Alright? So just like in the previous example, okay, so we factor out the numerators. First, the numerical coefficient. We have 12. The factors are 4 and 3. Then for 20, we have 4 and 5. Alright? So, x cubed here will no longer be factored out. Okay? Because we also have x cubed in the denominator. Then, y raised to 5. Then, we need to factor this out. Okay, the factors are y raised to 2, then y raised to 3. Then, in the other term, we have x raised to 5. So, we need to factor this out. The factors of this term, we have the factor of x raised to 5, rather, we have x cubed and x squared. Then, y squared, we do not need to factor this out. Then, z is remained. Alright, then, we will do the cancellation. Okay, so cancel this out, this one, and this one also. So what will remain in the first term, we have 3y cubed. The negative, what will remain as in the second term, we have negative 5x squared z. Alright, then last steps, we have write the complete factored form. Okay, the complete factored form of this given expression, we have 4x cubed y squared times quantity 3y cubed minus 5x squared z. Okay, let us continue. Example number 4. Write the expression 12x cubed minus 18xy plus 24x in complete factored form. Okay, we will follow the same steps. Determine the number of terms. So the number of terms that we have in a given expression, we have 3. Alright? Okay, 12x cubed, negative 18xy, then positive 24x. Then determine the GCF of the numerical coefficient. Okay, these are the process. So these are the numerical coefficients. The factors of 12, then the factors of 18, then the factors of 24. Then we will determine the common factors. We have 1, we have 2, then we have 3, then we have also 6. Then 6 is the greatest common factor. So that's why we choose 6. So this is now the GCF of the numerical coefficients 12, 18, and 24. Okay, next step, determine the GCF of the variables. The GCF of the variables is the one with the least exponent and is common to every term. Alright, so these are the variables in each term. We have x and y. So first, we will work with x. So we will choose the one with the least exponent. So this is it, x. Then the next variable, we have y. So since y is not common, so we do not have the GCF for y. So this is now the GCF of the variables. Okay, next step, we have find the product of GCF of the numerical coefficient and the variables. Okay, let us multiply. Okay, this is the GCF of the numerical coefficient and the variable. Okay, so the result is 6x. Then, hence 6x is the GCMF of this given expression. 12x cubed, 18xy, 24x. Okay, again, 6x is the GCMF of each term of the given expression. We have 12x cubed, 18xy, and 24x. Next step, find the other factor by dividing its term of the polynomial by the GCMF which is 6x. Okay, these are the process, right? So we need to factor out the numerators. So first, the numerical coefficient. The factors of 12 are 6 and 2. Factors of 18, we have 6 and 3. The factors of 24, we have 6 and 4. Alright? So, we need to factor out also our variable x in the numerator, because the exponent of the variable x in the denominator is 1. So, the factors of x cubed, we have x and x squared. Then, here, so we do not need to factor xy. Then, so with x here. Then, we do the cancellation. Cancel this out, and cancel this out. So, what will remain in the first term? We have 2x squared. Then, in the second term, we have negative 3y. In the third term, we have positive 4. So, this is now the other factor that we are looking for. Okay. Next step, we have write the complete factored form. Okay, the complete factored form of this given expression is 6x times quantity 2x squared minus 3y plus 4. Okay, next example. Okay, write the expression 28x cubed z squared minus 14x squared y cubed plus 36yz raised to 4 in complete factored form. Okay, we will do the same. Alright, so the number of terms that we have here, we have 3 terms, 1, 2, and 3. Then, we will determine the GCF of each numerical coefficient by doing the same process. So these are the numerical coefficients, the factors of 28, the factors of 14, the factors of 36. So then determine the common factors. We have 1, then we have 2. So we only have 2 common factors. Then we will choose 2 because 2 is the greatest common factor. Okay, so 2 is the GCF of 28, 14, and 36. Alright, next step. Then, we will also determine the GCF of the variables by doing the same. Okay, these are the variables of the given expression. We have x, y, and z. Now, for variable x, we do not have x in the third term, so meaning x is not common. Then y also is not common. Then x also is not common to all the terms. So, automatically, our GCF for these variables is 1. We will make use of the numerical coefficient, which is 1, imaginary, in this case. Alright? So, next step, find the product of the GCF of the numerical coefficient and the variables. So, we will multiply 2 and 1. The result is 2. So, hence, 2 is the GCMF now. So, next step, find the other factor by dividing each term of the polynomial. This is the polynomial. We will divide this one by our GCMF, which is 2. Okay, these are the process. Alright? So, first, we factor the numerators. So, the numerical coefficient, 28. The factors are 2 and 14. We have 14 here. The factors are 2 and 7. Then 36, the factors are 2 and 18. Since we do not have variables in the denominator, so our variables in the numerator, no need to factor out. Alright? Then we will do the cancellation. So cancel this one, and this one also. So what will remain in the first term? We have 14x cubed z squared. Then in the second term, we have negative 7x squared y cubed. Then in the third term, we have positive 18yz raised to 4. Okay? Then next step, write the complete factored form. Okay? And this is the complete factored form of this given expression. 2 times quantity 14x cubed z squared minus 7x squared y cubed plus 18yz raised to 4. Right. So, below is the summary of the steps of factoring polynomials by the greatest common monomial factor. Number 1, determine the number of terms. Number 2, find the greatest common factor of the numerical coefficients. Number 3, find the variable with the least exponent that appears in each term of the polynomial. It serves as the GCF of the variables. And number 4, get the product of the greatest common factor of the numerical coefficient, and the variables. It serves as the greatest common monomial factor of the given polynomial. Then number 5, find the other factor by dividing the given polynomial by its greatest common monomial factor. Then lastly, write the final factor form of the polynomial. Alright, so thank you guys for watching. I hope you learned something. And guys, don't forget to subscribe and hit that bell button to be notified with the latest video. Happy learning!